Hey everybody. So we are at the third and final step of cellular respiration. This is the electron transport chain. This is our goal from the beginning, to make sure we have enough ATP and coenzymes, also known as electron carriers, um, to get them to the final step, which is this process, the electron transport chain. This is where we're going to create a ton of ATP. In fact, it's probably about 90% or more of the total ATP created is in this step. So, what's really important to understand is number one, it's still in the mitochondria. All right, so we still need oxygen. Also, this is a process where we're going to need those energized electrons, the ones that we've been creating throughout the first two steps, glycolysis and the Krebs cycle. So, these are the coenzymes or electron carriers that we discussed earlier. We need NADH and FADH2. We've been creating these all throughout glycolysis and the Krebs cycle. Now we can use them. Their goal is to be an electron carrier that's going to help generate the creation of ATP in the transport chain. Oxygen's role: oxygen, as we mentioned, is very electronegative, and therefore it's going to pull these electrons that are found in NADH and FADH2 down the electron transport chain to a lower state of energy. So this is going to help create the energy needed for the ATP synthesis. This process is also known as oxidative phosphorylation. All right, because oxidation is occurring and we are phosphorylating. Phosphorylating means you're taking phosphate and you're adding it to ADP to make ATP. Right, so ADP, got an A, two P's. We need a phosphate. Let's phosphorylate it. Let's add a phosphate to it. Okay, where do you get the energy? It all has to do with these these coenzymes. We're going to come in, and this energy of these guys being pulled by the oxygen is going to create the energy needed to phosphorylate the ADPs into ATP. All right. That said, we can see that here in this image here. When this happens, the hydrogens from the NADH and the FADH2 are going to be released, and they are going to bind with the oxygen that was inhaled and create water. So this is where the water comes from in cellular respiration. So we also exhale the water. As you can see here, the energy that is extracted from these two coenzymes is going to be used to add a phosphate to the ADP and create ATP. Where is this done? Because it just doesn't happen in the middle of nowhere. It happens inside the ATP synthase. All right, this is a enzyme that is whose goal and its job is to take the ADP and turn it into ATP. This is where the oxidative phosphorylation occurs. So with that said, this process is going to generate a ton of ATP. Okay, so over 90% of the ATP generated in cellular respiration happens at this step. So as a really quick overview, we had glycolysis, which was going to create a little bit of ATP, a little bit of NAD. Then we had the Krebs cycle, or the citric acid cycle, and in that case, we are also creating a little bit of ATP. We're also making FADH2 as well as NADH. So now we have a bunch of these little electron carriers, also known as coenzymes, the NADH and the FADH2, as well as some ATPs. And all of those are going to meet in this last step where we are going to get a mass production of ATP using the ATP synthase enzyme. All right, it's all because of the energy we got from these coenzymes. So again, this is a brief overview. If you want to see this in more detail, you can look at the slides, read the book, and check out videos online with better animations to fully understand what's going on in this process. If you have any questions, please let me know.